Okay, so we've been working on the product rule of radicals, combining them so that we can simplify. Now we're going to have the quotient rule of radicals. We're going to be doing some divisions. So when you look at this and you start copying this down, I've got a basically a left and a right part of this formula type thing. And then based on that, we'll have two rules. So as we go through and we start simplifying, in any problem, you're going to want to say, can I satisfy all three rules? Are all three rules satisfied? If they are, then I know I've simplified as far as I can. So always look through, especially these. If there's division sign in the problem, rule 2, rule 3 will apply. Not so much when there is not a division. Okay. So what we have is the nth root of a divided by nth root of b. Sometimes you're going to see problems that look like this. Sometimes you're going to see a problem that looks like this. This is the nth root of a divided by b. Okay? They're equivalent, but as we approach them, depending on what information we have, square roots, cube roots, what the values are for a and b, I do need to make a change. I wanted this to be b in the same fashion. As I already told you that capitalization matters. Depending on the values we have and what root we are, you may have to approach it this way, or you may have to put it this way. Okay? Nth root of a over the nth root of b. Indexes match, we can combine them to do the division. Okay? So rule 2, no fraction within a radical. No fraction within a radical. Okay, so when you look at that, no fraction within a radical, if we see that, hopefully you're saying, well, this fraction is within this radical. So you're saying, if we have a problem like this, we don't want that. Now, when we have that fraction in a radical, look to see if you can reduce that fraction. Okay, look to see if you can reduce whatever this is. Maybe you can use the product rule, quotient rule, those rules. Maybe you can just do a division. But be mindful, sometimes as you reduce that, you reduce away from perfect squares, perfect cubes. So you do want to be careful. You may make the problem longer. Okay? When I see this, no fraction within a radical, if I have this, what I would usually do is I try to split it up so that I can take out nth powered factors, that rule 1. Generally, I look at it is, if I recognize this as a perfect square, perfect cube, if I split it up, that's something easy to evaluate at that point. So if it was the square root of 4, I'd have 2. Okay? Well, this dealt with this. Well, rule 3 is going to deal with this. Rule 3 says no radical in the denominator of a fraction. No radical in the denominator of a fraction. So when I look at this, I've got a radical in the denominator of the fraction. So what I would want to do is to take this and put it together and see if maybe I could reduce that. So no radical in the denominator of a fraction. We're going to get to a point where we're going to have to add to this, because when we put it together, we may not be able to simplify. We still may have a radical in the denominator. We'll need an alternate process, and that'll be some clips down the way. Okay? So when we look at that, we got the 3 rules. Rule 1, most always prevalent. Remove nth powered factors. If it's a square root, remove perfect squares. If it's a cube root, remove perfect cubes. Rule 2, no fraction within a radical. Rule 3, no radical in the denominator of a fraction. Okay, so I'm going to erase and put one and see which we recognize. We'll start off semi-easy. Okay, we'll start with some numbers and we'll add some variables in. So when I look at this, I don't see a fraction within a radical. I do see a radical in the denominator of a fraction. Now, as we go through, we may not have to put it together into one if this is something I can evaluate. If this was square root of 4, square root of 9, square root of 16, if it was something that I could take care of, I'd evaluate that. I'd simplify that to that number. Square root of 3 is an irrational value. So I'm not going to be able to reduce that in terms of like square root of 4 becoming 2. So I have to look at it and say I can't have a radical in the denominator of a fraction. So what I want to do is I want to put it together to see if that helps me. Square root and a square root is still a square root. Well, 75 divided by 3, well, I can reduce that. That becomes square root of 75 divided by 3 is 25. It becomes some negative value. Square root of 25 is 5. Okay, so sometimes when you have the original, maybe put it together to see if you can reduce, gets us something that we can evaluate. Remember, try to approach these as if we don't have a calculator. What process could we go through? So if I have that was split up, so I will do it's 50. Okay, so if I go through and try to simplify this, I look at it. Now, I always look to see if I can simplify what the radicand is. Okay, so I could use the quotient rule here, simplify that. I could divide out a common factor, but I want to get in the habit of looking at the denominator. Right now, I can't. I've got a fraction and a radical, so I'm violating rule 2. I know I'm also violating rule 1 because these powers are greater than this index. So there's factors I can take out. When I look at this, sometimes simplifying, especially 50 divided by 4, sometimes I reduce away from perfect squares. I recognize 4 as a perfect square, but if I divide out that 2, I have a 2 here. It leads to a process that's going to be longer, and we haven't gotten that far yet. So right now I'm just going to split this up because I do recognize that 4 is a perfect square. It's going to allow me to evaluate that. Well, as I start simplifying, I'm going to start with the denominator in this case. Square root of 4, remember I can split this up. I can split this up as square root of 4 times square root of, now I'm going to break that down, a squared times 2 times a squared. Square root of 4 is 2. Take an a out, that's a squared. Or if I'd done the division, 4 divided by 2, I get 2a squared. That's a good value. Radical's gone. I no longer have a radical. But I still have this to take care of. So let's split that up. Square root of 25 times square root of 2. In 50 I know this is 25. 25 times 2. And then I can split it up a squared times a. Well, I know square root of 25, that's going to be 5. I'm going to take that a out. So I have this square root of 2. That 2's in, that a is still in. And that's still over 2a squared. Now that other process I talked about that we'll learn in a few later clips, we could do that and still arrive at the same answer. If we proceed in this manner, just remember, we always want to look to simplify. If that square root of 2a wasn't there, we'd still have information to simplify. Well, 5 and 2 don't divide into another, but a and a squared, I can cancel out that a, which means I can cancel out one of those a's. So my answer is 5 square root of 2a over 2a. Now please note, we cannot divide anything that is outside a radical with anything that is inside. Just the way we can't multiply anything that is outside a radical times anything that's inside a radical. So this 2 cannot divide into that 2. That a cannot divide into that a. Because this 2 and that a, it's not really 2 and a. It's 2a to the 1/2. It's the square root of it. So they wouldn't cancel. Remember, don't divide anything outside with anything inside. Okay. In the next clip, we will do a few more and some other things we need to worry about with these. Okay, remember, you're going to have one form and you can put it to the other or vice versa.